the chat. We want to make sure that we've got all our system settings going here. So.
Okay. I had said a couple things, but this is Kevin's class, but Kevin's out farming. He's working 16-hour days, kind of heroic in my opinion, I think. He does a lot of work out there, so he asked me to fill in for him. And so I'm filling in for Kevin. Tonight's class is about face milling. And didn't have a lot of time to prep for the class, but after prepping for it for about an hour, actually kind of learned some cool things myself. So excited for that. Kevin always needs ideas for his class. You submit your topics. We're going to send you a hat and shirt. And you guys can all hear me, so that's great. Okay. So I didn't really want to face a square part, so I thought I'd come up with something a little funner, so I made up a big wrench. Added some stock to it, added a couple nubs to mill off on the back here. Of course, the standard setup, I think we've all been through this. This is kind of a different class. You know, you set up your coordinate system. You define your stock. I like to model my stock up. You guys all know that. Target, of course, we've selected that. And today we're not going to be doing iMachining, so I'm not going to use iMachining. And let me delete this probing. Kevin had asked me to do a probing operation on here, but I'm just going to kind of skip that. That could be a different class as well. See if I can delete this guy now. Okay, so we're all kind of starting from scratch. Got a coordinate system on here. And there's a lot of things going on with face milling, to be honest. Back when I first started with SolidCAM, there was no face milling module. We either had to use profile or pocket and then manipulate the toolpaths to kind of to do what we wanted to. So I, in my opinion, kind of consider face milling what I call a canned operation, kind of like the toolbox cycles, made easy for the user. They're always open geometries, so you're not going to get a face mill operation to go up against the wall. In order to do that, you're going to have to use a profile strategy or a pocketing strategy. But there are very cool things going on with face milling. One thing to keep in mind, and it's very helpful for even us application engineers at SolidCAM, is the help menu. The help menu covers every topic that there is in SolidCAM. So if you ever have a question, and I can kind of show you guys how to get there, you just go to help. And if we go to SolidCAM help topics, we're going to go to milling. And then what you do in here is you type in a phrase. Say we type in face milling. Then you're going to go ahead and you're going to select list topics. You're going to find a topic and you're going to display that topic. And this is kind of how I set up the class because, well, you know, I've been working with the software maybe, you know, 6, 7, maybe 8 years. As a customer, probably 4 years, and now I've been on board about 4 years. I'm still learning things every single day with this software. And a lot of that is just right here in the help menu. And it's really simple to get to. And so I come in here and I start looking at how geometries are created, and I start reading, and I start seeing things like, oh, okay, wait, you can do a box and you can do a silhouette? That's really cool. So if I had, you know, something with a hole in the middle here, select silhouette, well, it's going to avoid cutting all that air in the middle. Other things too, like you can actually join two bosses together. So separate chains, merge chains. I just learned that today, you know, just going right to the help menu. You know, these things are really cool. Some things we take for granted, but really these operations are very powerful, even, you know, something as simple as face milling. You know, modifying the offset just like we do in a pocket or a profile. So we're going to kind of cover these things on the fly. I thought a box would be kind of boring, so I drew up a real big wrench. So let's say we get a really big wrench, a forging that we need this wrench, but we have to machine it down so it needs to fit in the slot or something. So we need to take all this stock off. So we're going to go ahead and add our facing operation. Now, this is kind of neat. I don't know if this is what SolidCAM is doing now or not. I need to investigate this, but keep in mind I'm working in 2016, but it's automatically popping up this wire or this automatic box here for the face mill, so it would face it off. But I'm going to go ahead and create my own. It's really neat. Yeah, I don't know if it's
That's cool, Justin. I think that's a 2016 feature that it's actually grabbing the minimum extents box and creating that geometry for you on the fly when you start your project. It must be doing that.
Exactly. That's exactly what it's doing. So now with this wrench, we got 3 options that are pretty much going to give you the same result. And the reason for that is because we don't have a lot of complex geometry. For instance, if we had a part that had a lot of different levels that was very prismatic, well, then you might want to just select the model, click the model, and then it'll put a silhouette around it. And then you could either select box or silhouette. You could select individual faces, or you can chain profiles. All 3 of these tools are just tools to get you the geometry you need from any part. And in this case, all 3 of these options are going to give us the same result. But again, if I had slots cut out of here, surfaces, weird things going on, you might be limited to one of these, like for instance, a profile or a face or the entire model. So they're just different animals of getting what you need. So let's start off with model. Now, this is one thing that's always, it gets me to this day, and it gets all of my customers, is that this is the only operation that you're ever going to have to click things twice in the geometry field. So first you're going to select the type of, or how you want to get the geometry under type, and then you're going to select define. It would be nice if these were just a button. I could probably put that in as a feature request, but in this case you're going to have to click it twice. And even as I was trying to prep for the demo, I kept slipping up and not hitting the define. So this time we're going to start off with model, and we're going to select define. Then that puts us into our 3D geometry. So you have your CAD selection that you can either pull out of your tree and get individual models if you're working in assemblies, or you can just go ahead and select the 3D model. In this case, I want to select the stock or the target, and it'll give you the same result, but typically you would want to select the stock because you're removing the face of the stock. So we're going to accept that. And now because I selected box, it's going to give me the automatic box. I could do silhouette as well. Again, with faces, I can do box or silhouette. This time, let's do silhouette. And then define. And then we're going to select a face. I'll select my stock face. And it's going to give me a profile. Same thing with profile. Like I said, we're going to get the same result 3 times with this because the geometry is so basic. It's going to do the same thing. But if I do profile this time, let's mix it up a little bit. Let's see if it'll give me a box. Maybe it won't. I'll go and do my constant Z propagation here. Chain it all the way around. And what do I get? Just profile. So we're restricted to profile within profile. So we don't get the either box or silhouette. So good to know. In this case, I'm going to go ahead and to avoid cutting air, because this is actually a very big part. This is a big wrench. And just to kind of measure it here. If I do an evaluation, just to kind of give you the scale of this. This is a 5-inch. This is a 10-inch. So inside here, this is for a very big wrench. So we got a 5-inch wrench here. So obviously, like a 2-inch face mill, it's going to be relatively small, or it's going to be removing a lot of material. So in that case, I want to try to avoid cutting air by doing the box and cutting outside here. I want to try to eliminate that. So now let's go ahead and select a tool. I think a lot of you know how to import the tool, but I'm gonna go ahead and do this on the fly. I'm gonna do a face mill. And I'm gonna pick the picture here, and let's build a face mill that looks more like what we have out on our shop. So typically face mills are about 3 inches in diameter. So that's 3 inches from here and here. And if you look at any of these fields right here, if you see D reflects the outside. We'll go ahead and do all inserts have a radius. Typically they have anywhere from 8 to 15 thou. For a lot of roughing, you want a robust insert, so maybe a big radius on there. 90-degree is not good for carbon steel. 90-degree shoulder mills are only really good for aluminum or shouldering. So typically, if you go to your tool manufacturer, they're going to try to recommend something that's probably like at a 45-degree angle. And that's going to kind of create a chip thinning effect, and it's going to actually help the insert. What's neat, and I noticed this button here, I think this just kind of locks that in right there. I think that's pretty cool. So you can't mess it up. Arbor diameter. Let's do a 2.5 arbor diameter. So it's starting to look more like a face mill. Let me get this out of the way. And you guys forgive me, this is my first time with GoToWebinar, so I'm going to kind of fumble around with that as well. So let me see if I can minimize this back. There we go. I got more of a screen now. Shoulder diameter. So that's the inner section of this here. So we'll go ahead and we'll make that probably about 2 inches. Now, looks starting to look even better. Total length, okay, so this would go to your Cat 40 holder. Typically, the Cat 40 holder has a lock nut right here. You lock that in, and then the total length would come from that Cat 40 holder here. And this could be important because we have the capability in 2016 to gouge check against the Cat 40 holder in 3D iMachining and in HSR. So if you need to dig that tool into a deep cavity, these parameters are very important. Okay. So outside of the holder, we're going to probably want to do 2 inches. Shoulder length, this is second shoulder length, this is shoulder length. So it kind of gives you this little taper right here. So, but first I'm going to go to the cutting length because the cutting length is very, very important when you're face milling. Tool manufacturers will recommend that you never go past the insert screw. So even though your insert might be a ½ inch deep, you don't want to go past that insert screw because then you're going to cause vibration and maybe cause that insert to come loose. So typically what I'll do with this cutting length is I'll put it to my insert screw. So, you know, just kind of guesstimating, it's, maybe that would be about 250 thousandths. Don't need 2 decimal places. Okay. Now we're looking at shoulder length. Shoulder length should just be a little bit above that. Okay, and then my second shoulder length doesn't need to be that big as well. Now we have something that looks like a nice face mill. So we'll go ahead and accept that. We'll give it a name as well. So we'll call this my 3 inch. And it's, you guys, it's always important to put something in this field because you'll get blank parentheses if you don't. And I always stress in all my training that you fill out all of this tool data correctly right from the get-go. That way, anytime you grab this tool, that information is already in there. And also, if you make a library out of this tool, that information is already there. So you might as well do it right the first time. So we're going to call this 3 inch, 45 degree face mill, something like that. Okay. Now we're going to go into our tool data. Now, face milling is actually just as effective as iMachining in certain ways because what you can do is you can take a very wide step over rather than a very deep cut. And you could also run very, very fast. So if you're cutting like carbon steel or stainless steel, you can actually run these inserts dry and run them at phenomenal speeds and feeds, maybe 800, 700 surface feet, and just rip through material. What's happening with a face mill is what is happening is called an interruptive cut. So every time the insert comes into a cut and leaves a cut, it's heating and cooling. So by leaving that coolant off only with carbon materials and stainless steels, you're actually keeping the insert happy. It's actually cooling itself as it's doing the interruptive cut. Now with aluminum, you would always want to run coolant. You won't get away with that. But with carbon steels and stainless steels, it's very happy to cut dry. So let's go ahead and run, we'll say this wrench is some kind of carbon steel. We'll run 700 surface feet. So that's giving me around 1,000. Still don't think that's fast enough. Let's go 1,000 surface feet. Okay, I'm starting to get in the 1,500 range. And keep in mind, this is a 3 inch face mill, so it's going fast. We want to make a nice chip, so we'll do about an 8 thou per rev. And then finishing on X and Y, whatever it takes to make it look nice. Okay, So now we're going to go ahead, and we don't need to necessarily add a holder unless we're going into a deep cavity, and then also your coolant on here as well. So we'll go ahead and do that. Okay, levels. Another new feature here in 2016 is our milling levels. And you can actually do your levels automatically by stock or target or user defined. So if I go ahead and click by stock, automatically puts in my upper level, so it knows where my stock is. Now look at my coordinate system. It's actually on the face. And I'm glad that I brought that up because as a machinist, I like to remove positive material and cut it away. That way when I'm on the face, that's 0. So all this would be positive material. So rather than put my coordinate system on the top and then guess where this Z0 is, I like to do it the other way around. I like to find the Z0 and then cut the positive material off the top. That's just my personal preference and how I like to do things. So now I'll go ahead and pick a step down, so 200 thousandths. Technology. Now here's where everything gets kind of fun. You got all kinds of different options in here how to attack a part like this. Obviously, for face milling, there's going to be a lot of air cutting here. You got your hatch, your contour, your one pass, and your spiral. Now, just to kind of go back to our help menu, if I go to, I think it's face milling operation display, you get those options right here. You got face milling, linear, contours, one pass, and spiral. So any information you guys need is right inside here. How to use it and all the tricks. Now for this part, spiral is not going to be good. Hatch, contour is probably going to be what we're going to do. If we had a wide enough tool, we might get away with it in one pass. So in this one, let's look at the options between hatch and contour. So first we'll go into hatch. This is an important field as well, and this is important also in our pocketing operation is minimum overlap. Minimum overlap to me is kind of opposite of the way we think in the shop. We would think of overlap, but I guess it really doesn't matter, minimum or overlap. But in this case, SolidCAM is minimum overlap. So that means that if I'm 30% minimum, I'm 70% engaged. That's the heaviest. Typically, tool manufacturers are going to want you to stay off the center of the tool. That's bad news for the tool. So they're going to say you're going to be 70% radially engaged, which is the max, or 30% radially engaged, which is the minimum. So this is opposite. So minimum, this would give me 70% radial engagement. You can also do a value. You can see that's 0.9. You have one layer zigzag. I would never conventional cut with a face mill. Toolpath reverse, just switches it around, pretty cool. Cut order to complete Z level. So if you had different pockets, basically, it would complete the Z level on each pocket, so it would go back and forth. And then optimize your cutting chain as well. Not 100% clear what that does. I'd have to play around with it. So again, that's like a good example. You know, I've been working with the software for a long time and still learning things. So even in face milling. Here we have our floor offset. Face milling creates a lot of tool loads, so it's always good to leave something nice and easy for it to face off. So maybe we'll do a 15 thousandths offset. Click to finish so that it knows that it needs to finish. And if you notice, when you select one of these, you're going to get different tabs. And this happens a lot in our pocketing strategies or eye machining strategies. Anything you do, when you start checking things on in this parent tab here, then you see little tabs, new tabs pop up. So if I do contour, then you're going to get contour tabs. So we're going to do hatch, and we're going to have our hatch tab. Here we have the way to optimize the angle, so you can do any type of angle that you need. Automatic optimal angle from delta from optimal, so it's going to optimize where it thinks it cuts the material the fastest. I like to do the user define, so we'll try 90. Extensions along and across, so two directions. Along and across, whichever way it's going, will depend on whether it's along or across. Advanced for face milling is only ever going to have one button, and that's if you have multiple parts, you can optimize the sorting. I hardly ever use that. So that pretty much covers this page. For hatching, we'll go into link, and here we have the standard lead in and lead outs as well. So tangent, same as lead in. Actually, we only get tangent with hatching, and there's probably a reason for that. Your extension, your length, your angle, and your normal. We'll generate that. Floor offset is greater than depth. Now, how did that happen? So let's go to our levels. Face depth. We don't have a depth in there. That's why. There we go. And there we go. Let's look at the wireframe. And so it's going straight up, straight across, back and forth. Here, here. We might like that. Let's take a look. With face milling, it's always important as well is to watch that first move because you never want to plunge with your face mill. So I always do that first step down and look at it go across. Boom, 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 boom. Actually, it looks pretty good. I like it. It has a nice finish pass as well. It looks good. Okay, but let's look at some of the other strategies for this particular part. Let's try contour. Maybe that'll cut less air. Using the same parameters, let's see what we get. Okay, that looks nice, but I'm noticing one thing here. Looks like I'm plunging into the part, so let's figure out why. Oh yeah, plunging right on the part. So obviously I'm seeing that it's taking the center line of the tool. But I like this tool path better because it's cutting way less air. So let's just get it to drop outside. This is pretty cool. You can actually make a fillet or a loop. Hopefully you guys, I'm trying to point down here, but if I point down here, it switches the picture, but you can see you can do a loop. You can make it sharp on the corners or none and just make them straight. Direction type. This one is really important. I really find that the rounded entry to it kind of just helps wiggle that tool into the next cut. Smooth kind of does the same thing. When it goes to that next pass, rather than going straight in, it kind of eases into it, kind of more of like a lead in or kind of, you know, of an eye machining almost type deal, where it's actually just helping that chip that chip thickness to kind of stay nice and clean. You don't want to slam your tool in 90-degree increments. It always is a bad situation. So let's look at the extension here. The extension says the tool path's going to extend outside that. I don't think that's going to help me. So I'm going to have to go into my links here and go ahead and do a normal or an arc. There's an arc there. Now I got it dropping down and around. 60% of the tool. That's 10% past. Now that's a very optimized tool path. So let's look at that run. I like that one over hatch. I think it's cleaner, less air time, and it might even give us a better finish, kind of a cool finish on the end. Now the other one here, let's go back to our technology, is one pass. Obviously one pass is not going to work on this because the tool will not go over it in one pass. So you're going to get a poor result. And the other one is spiral. I don't think spiral is a good one for this one as well. But let's look at see what happens. Okay, so it tries to make a spiral at it, but really it's kind of funky. The geometry is just not good for a spiral. But I would like to show you when spiral is very effective, and that would be on a square part. So I'm going to go ahead and switch over to my standard demo part. I'm going to go into the gate box. And on the second operation here, and I already set this up, I want to show you something. what I want to show you is that on the first operation, we've completed everything and we got some really big rest material out of here. And I've had this happen to me in the past, and it is very scary, is when you take a chunk of aluminum or a chunk of steel or any material you're cutting and you throw it across your machine using a face mill. And the reason is because you come straight across, and as the end mill is coming across, it breaks a little piece right here. That end mill catches it and just hits it and just slams it across the machine. Very dangerous, can break your tool, and can even actually really, really hurt someone. So in my opinion, when you have big pieces hanging off like this, then you want to use your spiral technique. And what that'll do is that'll come in and it'll slowly spiral it around. That way there's no chunks flying around. So that is my opinion. The purpose of spiral is to be able to get those ears or those big rest material chunks and not just knock them across the machine. All right, we'll go back to our wrench here. Okay, let's see if we're missing any other parameters. We have our linking. I think a lot of us understand what linking is, our lead in and lead outs. You have your links between passes. You can either go up to clearance level or you can go up to your safety distance. Pretty simple. No need for any of these options here. These are all advanced options. So we all, I think, agree that spiral is not going to work. Now, one pass would work great if the tool were big enough, but in that case, it's not. So I think contour is the winner here. We have our smooth adjacent connections. So I think we have the best tool path for this part. Now, there was one other thing that I was looking at in the help menu, and that wasn't under this. It was this guy right here, separate chains and merge change. When I saw this, I was like, what the heck? I can't believe I didn't know about this. This is totally awesome. And then obviously the offsets too work very well. If you need to offset the chain for whatever reason, you have the offset ability, so we should look at that. Just like you would in, well, actually it's in the chain. Just like you would in profile. So yeah, you got modify offset. So if I go ahead and modify it, for whatever reason you need to modify it, the option's there. So modify it bigger, smaller, whatever you need. You just have that ability to modify the offset, just like in profile. But as I was preparing this presentation, I wanted to demonstrate that option that I found in the help menu, which was merge chains. There's no chains to merge here, but so I've put on 2 nubs. So we can imagine I got this big wrench. I needed to face it down to change the size, and then also because of the mold or whatnot, they had these 2 little nubs on the back. So let's go ahead and we'll do a second one. This time we'll go to Mac 2, so I have it on the back side. And I want to do faces. Define, don't forget to click define. I still do it to this day. I want to cut that face, accept it. Now you have separate or merge. Separate, it'll come in, whomp, whomp, hop up and down, or merge comes down, whomp, comes across. So I'm going to go with merge. Grab the same tool. Now, I could also import a tool from my library. So if you need to come in here and import tools from your face mill, we built one from scratch. I'm actually going to add this to my library. I think it's a nice tool. Levels by target. This time we'll just do user defined. So I want my upper level of this guy and my face depth down here as well. Okay, step down, I want it to be 0. I want to cut those nubs off. I'm going to do 1 pass. We have our toolpath modification. So you have your angle, your shift from center. This one is important. I had somebody actually just call me the other day about this shift from center. So if we look at the tool path here, let's go ahead and generate it. It's going down the center. If you want to shift it from center, you could actually just shift that whole thing off center. See if it works. There it goes. It's working very very small. Let's shift it. There it goes. May be working in metric. Weird. Oh no, it's percentage. Okay, so we want to do 50%. There we go. So 50% shift off center or 0. Angle. Haven't played with this. And anxious to see what happens here. Totally kicks it off at an angle. Save and calculate that. Extension of the tool diameter. So it's going to be the tool diameter plus this, so you're safe at 10%. One pass, I like that. Don't need it in the lead in and lead outs. It's automatically at tangent. I'm going to come in here, drop the tool down, and we're going to cut those nubs off. Well, they're not part of the stock or a part of the target. Let me go back to my target. And let me add in these guys. I didn't merge them, so let me go ahead and just click those guys so we can see them get cut off. Cool. All right, we'll calculate that again, or just I think we should just have to simulate it. Doesn't look like I hit accept. Let me look again. They're on there. I just can't barely see them. Why am I not seeing them on here? For whatever reason today they're not showing up. I'll have to figure that out. Maybe because I did them after the fact. Doesn't matter. Let's do a host verification here. Nonetheless, we can see them getting cut off. Try to do a cleanup cam part.
Your updated stock looks like it's got an asterisk on it, doesn't it?
Yeah, it does. Maybe that's the new button that works. Tim's right on the money. Look at that. That's amazing. Well, they're still not showing up in my Solid Verify. Yeah, not a big deal. I'll figure that out.
Not a big deal. I think, yeah, I think everybody kind of gets the idea of what you're doing there.
Yep. But anyways, the main point was that we cut the nubs off, click the two faces, and merge the chains together. I think one last thing here. This is going to kind of be a little bit of a short class tonight because we don't have a lot to cover. As I mentioned earlier, and I don't know if you guys heard it or not because I was muted for a while or I wasn't broadcasting, but in the early days of SolidCAM, there was no face mill. It's kind of a canned operation to make things easier. So what we would have to do is either use profile or pocket. So, and sometimes if we want to go up against the shoulder or things like that, we need to use those options still to this day. Just a quick example of how we would do that. I'll just use Mac 1 here. Oops. So we'll do a pocketing operation. I can even borrow that geometry from the face mill operation. Or maybe not because I want to be able to reverse it. So let's go ahead and do a new one. That's climb cutting. That's another thing too, is that it doesn't matter how you create your chain in face. You can either climb cut or conventional cut. In a pocketing strategy or a profile strategy, you don't have that option. You're going to have to make that chain go to the same direction. So I want to go this way, so I'm climb cutting. Again, grab my tool. Again, do my levels. Same concept. Pocket depth. Step down. We'll do 0.2. Technology. Here it looks kind of the same, doesn't it? You have hatch or contour. Kind of neat. But the thing is now is that my geometry is closed. So if I do hatch or contour, it's going to shove that tool in here. So I have to come in here, edit this, and I have to make it open. You don't have to do that in face mill. So I have to mark chain as open. Now the tool can fall outside. So there's a lot more things I have to do here in Pocket to make it work the same. We want to stay off the tool center line, so we'll do a 30%. Now that I have open pocket selected, this open pocket tab shows up. Again, very important. As soon as I click that chain as open, this new tab shows up. It's important to know that. Again, if you're going to do contour or hatch, we're going to do the contour. We're going to use profile strategy, and we're going to approach from outside. Here's my extension. We'll do my links. We'll do a link, an arc in and an arc out. Let's see what we get. I have something that looks pretty dang similar to this guy. So if I go ahead and kind of refine this further, and let's look at our adjacent passes, and let's do a rounded. Getting pretty close, not identical, but pretty close. So that's how I would do it in the past.
Yep, and it's a good point, Justin. You know, the face milling operation, I think that came about in 2007, 2008 timeframe. That's back in the day when I was supporting the software. But you know, if you're trying to do a facing operation and not able to get it exactly the way you want to, you know, you can use the pocketing or profiling operations to do the same thing.
Exactly.
You know, because it does the same thing. You don't have to use the face milling operation. So that those other operations are another way to do it with a few more options. The face milling operation came along to make it easier for the user for doing those shallow depth cuts.
And profile as well. I mean, you know, back in the day, there was no engraving. I would do all my 4th axis, all my 5-axis engraving with profile. You know, I would just chain it, and it would be a tool on center line, and it would do the profile. Kind of the same situation. I think that's all I got, you guys. I hope you guys you know, enjoyed me being here in place of Kevin. Again, Kevin's out farming. You know, feeding America. I think that's really cool. And
actually, I tried to get a hold of Kevin earlier, and I seen he was online, and so I pinged him, and sure enough, he showed up, and he had his webcam on, and he's driving around in his tractor.
Yep.
So.
That. The last thing we kind of wrap it up with is the tell a friend. So basically, if you tell a friend about SolidCAM, and you know they get a demo, and well, I don't know exactly what this is. Send your contacts that have interest in integrated CAM. If they see a demo, you get paid. If they buy, you get even more money. Simple as that.
Exactly. So the idea is, you know, tell your friend, you know, what you're using, and if we get them to sit in and do a demonstration with us, you know, we normally send out a $50 gift card to you for recommending that to us to that guy. But you know, like Kevin's got a little special thing that for a KevCAM special, he'll double it, and you can get a $100 gift card. So just kind of Kevin's little extra bonus there. Anybody have any questions about you know, what you've seen, or I noticed there hasn't been a lot of questions there, but is there anything that Justin can kind of answer here while we got him online with us for a few more minutes?
Well, one of them was for Rodney, was to actually make these nubs part of your stock. I think I'm going to do that. I think that was a good idea, rather than the target.
Yeah, that's a good point.
So now if we go to simulate this, and there they are. Thanks, Rodney.
Yep. Nice call.
Now I get to see the nubs get cut off. Synchronize. Thanks, Justin. Very nice class. I enjoyed KevCAM. Thanks, Rick.
We like the comments there.
Yeah. Any other question, you guys? Just go ahead and ping them in now if you have any. And I enjoyed having you guys here. I had a good time.
Yeah, nice job with the class there, Justin. I'm used to being in demos, so it was a class. Good job with the presentation of showing the face milling operation and a little bit more. So everybody that was here with us, appreciate your time this evening. For Justin, it's this afternoon still, but some of us are getting ready for bed over here on the East Coast. So, so have a good night, everybody.
All right, you guys. Thanks.